This video is on the objective determine the p-value for a hypothesis test for the mean. And this is with population standard deviation known. Okay, so sigma is known, meaning that our test statistic will be a z-score. Right? We'll be dealing with the normal distribution. And this is number 2, okay, second video on a question related to this objective from your Newton-Alta homework that I'm looking at. Alright, so let's take a look. Alright, so here's the question. Again, if you want to see some more instruction, please click on the More Instruction button, look at their videos, their notes, their examples, and hopefully they help you out. Alright, so we're asked simply, what is the p-value of a right-tailed one-mean hypothesis test? And they give us the test statistic, so that we're not given any samples or hypotheses. We're just, the test statistic for our sample mean was this z-score, and z equals 0.36, right? So our sample mean is 0.36 standard deviations above the assumed population mean from the null hypothesis, whatever that is. And it says, do not round your answers, compute your answers from the table below. All right, so again, I'll draw a little picture. And remember, I went over this in the first video, so I'm not going to bring up all those pages again. When I'm calculating the p-value in a right-tailed test, I'm going to be finding the area under the curve to the right of my test statistic. And that's it. There's no doubling or anything like with a two-tailed test. Right? It's just simply going to be the area to the right of my test statistic. Right, so I'll go to a piece of paper here. Now, we're in the situation where the population standard deviation is known, sigma is known, so we eventually end up looking at the standard normal distribution, right? The z distribution, that normal distribution with a mean of 0 and a standard deviation of 1. Right? Underneath the peak is a z-score of 0. Right? Now, they told us, our test statistic is 0.36, right? So like a little bit more than 0 here, 0.36. There's our z-score, our test. I like to call it z-test. Right? Now this is again, it's a right-tailed test, and let me write that up here. Right, this is a right-tailed test. So in a right-tailed test, right, the p-value of the test statistic is simply the area under the curve to the right. And I'll write that again down here. The p-value in a right-tailed test is simply area to the right of the test statistic. And in a left-tailed test, it's the area to the left, right? And in a two-tailed test, it was either the area to the right doubled, right, if you were to the right of the mean, or it was the area to the left doubled if you were to the left of the mean, right? Okay, now I can find this with a calculator. Right? I know they said use the table, and I will in a second, but I got my calculator up here. Remember how to find the area under a normal curve, right? This is standard normal here. I go to distributions, normal CDF. You've seen this plenty of times by now. Now the lower value in here is my test statistic, 0.36. There is no upper value, right? It's this entire, all the way to the right forever. So to indicate that, I'm just going to put some large positive number, positive 99999. Mean 0, standard deviation 1, right? It's the standard normal. If you have an older one, you're going to have to enter your lower value, comma, upper value, comma, mean, comma, standard deviation. And this area is about 0.359, almost 36%. And that would be considered the p-value. Right, so again, this area is approximately 0.359. Right. So the p-value is 35.9%, 0.359. And then to make your decisions about, do I reject the null hypothesis or not, remember, you're going to compare the p-value to the significance level. You compare it to alpha. And if the p-value is greater than or equal to alpha, or I'm sorry, less than or equal to alpha, if the p-value is less than or equal to alpha, you reject the null hypothesis. And if the p-value is greater than alpha, you don't reject the null hypothesis. But we're not doing that here. We're just asked for p-value. Now I'm going to point something else out here, because I'm going to go to the table in a second. We found the area to the right, and that's what we were asked to find, the p-value. It's 0.359. Now if the area to the right is 0.359, that means that this area to the left is 1 minus this. Remember, the total area is 1, or 100%. Now 1 minus this would be approximately 0.641. Now let me show you what the table gives us. Now remember, a table, when we look at these tables with z-scores, or these z-score tables, remember the numbers given to us in these z-score tables are areas to the left of that z-score. So when I look up my test statistic on this table, z equals 0.36, 0.3, so I'm in the first row, and then 0.36, I'm in this first row, 7th column. See how the number 0.641 shows up? This is the area to the left. All right, I wrote that here, 0.641. That's the area to the left, 0.641, of my test statistic. But I want the area to the right. I want it's a right-tailed test they mentioned. So I take 1 minus this, right? Subtract 0.641 from 1, and you get 0.359. And that's what we need to be entering, our p-value. So make sure, so don't enter the value on the table if it's a right-tailed test. Now, if this was a left-tailed test, then I would just enter the number on the table. All right, but it's a right-tailed test, so I take the number on the table I found, 0.641, and subtract it from 1 to get 0.359 as my p-value. Okay, so pay attention, right, to what kind of a table. And again, they show you a little picture here. Please read the answer explanations. Right? If you got it right, read it to make sure that your reasoning was correct. And if you got it wrong, of course, read through the answer explanations and see, if you can figure out where you went wrong. So that way the next time, you see a problem like that, hopefully you'll do better. All right, and so hopefully these couple videos I put out too on this objective help you when you're working on this on your own. And thank you very much for watching.